Hello everyone, so today we're going to talk about RAG. What is RAG? RAG is Retrieval Augmented Generation. Okay. What that basically means is creating a chatbot that is talking to a backing store, right? So we've got chatbot, we've got a little terrible chat uh, icon there. And what this has is a backing store. And that backing store is a thing called a vector database. And the data in that is generated by another little AI model called an embedding model. Okay, we're giving that a different antenna, so we know it's a different thing. And what happens is you have a collection of files or other data that the embedding model puts into a sort of numeric format in the vector store. And then when you ask the main model questions, what actually happens is the software queries the vector store to find relevant information, and then it passes it back to the main model. Okay, so you'll see this a lot sort of demoed as creating a chatbot for your business, and they'll do something like they'll point this rather than at files, maybe at your business's website, and then show you a nice chat interface or possibly not so nice chat interface for querying your documents. And I've actually set this up here with the documentation for UCL ARC's HPC systems. So I pulled the raw text out of the website and I've put it in a folder here called data. And then I'm using a short Python program. It's according to the lovely Visual Studio Code, 73 lines long, which uses a piece of software called Llama Index to put the documents into this embedding model here, which is called IBM Granite Embedding 125 million. And then I'm using another IBM Granite model, a chat model, 3.28 billion instruct, to actually query it. So this means I can ask our documentation questions like, how do I log into Myriad, right? Myriad is one of our high performance computing systems. So what's happening now is it's querying the vector database and then putting those results into the Granite chat model, and then that will summarize the results, right? And here we have some nice instructions, right? It says SSH into your user ID at Myriad, that's correct. Got some instructions how to use PuTTY if you're using Windows. It also tells you how to log in to specific login nodes, right? So what it's done is it's looked at these files, and actually we can have a look at this. We look in data. It's actually a symlink to data RC docs. And in there, I've got all the markdown. You can actually see this markdown. There's a GitHub repository which builds our website. This is a very simple thing to set up, right? And you can give it other data. I'm sure I've done demos that you've seen with me doing it to out of print Lovecraft books, that kind of thing. So that's fine. So 73 lines of code. It's not that hard. You can follow a guide. Python is easy. One of the things that's moderately interesting is a lot of people are looking at if you can do this in a sort of low code, non code way. And so I thought what I'd do is set up a similar setup on our private cloud Condenser. So what I'm going to do now, I'm going to use the same GPU. And I've got Docker installed on here. It's currently running no containers, but I've already got a container set up using a piece of software called vLLM. vLLM is very cool because it gives you a endpoint that looks like an OpenAI endpoint. Okay, so if I do docker ps say, we can see I have an existing Docker container that I can just start. So let's do that. So we do docker start vLLM, and hopefully that will fire up in the background. Okay, but so going back to the start, this fairly terrible diagram I drew here, right? What this is doing is serving a model that does this part of the calculation. What about all the rest of the stuff? So we need an embedding model, and we have that Granite embedding model we talked about before. And so what I've done, and we also need some kind of web interface for building this chatbot. And there's a piece of software called n8n, which is sort of open source in that awkward way that things are open source where it's not quite an open source license. You're basically not allowed to use it to build a service that competes with their hosted service. And what I've done is I've actually installed this on another virtual machine on Condenser, and used our clever ingress. So if I'm inside UCL, right, I can connect to n8n.arc, general.condenser.arc, and so on. And it's got user IDs and things, so it's not open to the world. And this provides a very interesting sort of set of tools for creating workflows. I mean, the simplest thing is we could build a simple chatbot, right? So let's do this from scratch. What do we need to build a chatbot? Well, we need something that triggers the actual inference. So what I'm going to do is we're going to say on receiving a chat message. Okay, so we've added a chat message node. And then we're going to add an AI agent node. Okay. Have that connect together. You'll see it's got these other plugins we can do. And so we want to give this a bunch of things, right? We want to give it a model. And remember I said that vLLM lets us pretend to be an OpenAI instance. So let's do that. So let's add that in. And I've actually saved some settings in here for different accounts for different instances I've got. This is the instance for our vLLM instance. And actually, you can actually see that it's got the Granite model loaded in. Okay. And then finally, so there's some chat history. We're going to give it a simple memory, which will give it like a list of a number of previous interactions. We'll leave it at 5. That's plenty fine for this. And so what we've actually built here is a little chatbot, right? And we can talk to it. So we can ask it questions like, tell me something about frogs. And what's happening is in the background, this is connecting to that endpoint, running that model that we have running in Docker, and returning the results, right? And because it's got a memory, we can say things like, what colors can they be? And it has the context from the previous messages, right? So that's very simple and easy to build. What's more complicated is doing RAG in this environment. You need, remember, if we go back to that diagram, you need quite a few components, right? So let's go back up to the workflows. So the simplest version of RAG that I think I've shown quite a lot is where you have like a book, right? And then you want to ask questions about the book. So what have we got here in the components? Well, I have, this is slightly annoying to navigate on my trackball. So we have two workflows in this workflow. There's a workflow that ingests a document or set of documents. In this case, it's going to pull a copy of At the Mountains of Madness from my S3 in MinIO. And because it's anonymous, it will just do that as if it's a web document. There's a whole bunch of tools in here for pulling other data, right? So you can add S3 buckets and all sorts of things in there as data sources. I'm going to use a trigger to do the ingestion, which is click a button. It will pull that document. And then we've got this thing here called a simple vector store. Again, it supports many vector stores. So if you're into things like Pinecone or a bunch of other things, you can have much more complicated ones, but this is one that comes as part of n8n. And we need to give it a data loader so it knows how to load documents. And then here I've pointed it at an embeddings model living in Ollama. What's Ollama? Well, Ollama is another service, a bit like vLLM, that you can use to serve things. And really the reason I've done it this way is I kind of wanted to show that this allows you to plug and play lots of different things. Where's that Ollama instance living? Well, if we look over on the machine that is running the n8n Docker container, right, I've also got an Ollama container running. And that is serving that IBM Granite embedding model. There's also a vLLM container serving the same thing, and that's because I was doing some stuff to compare how the components work, and I'll show using that later. But pretty much in the same way, right? There's a configuration where you set up an account, you tell it what embedded, what model from the list that it supports you want to use. And so it will use this Ollama install, which is another sort of a model server, to generate the embeddings. And then there's the top workflow, which is the chat workflow, right? So that's what happens. That's triggered by receiving a chat message. And that has this agent that's a question and answer agent. It has an OpenAI model. That's the same locally hosted Granite that we're using in our little chat example. But it talks to this vector store setup. It uses a thing called a vector store receiver, and then it talks into this configuration put here. So let's start the ingesting, right? So what's happening now is on our, and we might actually be able to see this in HTOP if we're quick. You can see that ollama this is running on CPU rather than GPU, so it's really thrashing the CPUs to generate the embedding models, right? And it's done that, so that's completed. And that now means we can ask the model things about At the Mountains of Madness, right? And I like to ask, as is sort of becoming traditional, did Danforth enjoy his trip? And we get our response, right? And again, as we frequently get, no, Danforth did not enjoy his trip. Um, and it describes where it's done, and it's pulled up from the context of that book, right? Where this is slightly frustrating, and I spend a bit of today shouting at this, I would say, is if we want to do the example we did where we are ingesting all of those files, right? And that's partly because actually both ollama and the vLLM model hosting seems to have some sort of limitations around the way it does the context window for the embedding model. And so whereas here on the like code version, right, I could ingest all 56 of those documents and process them. I really struggled to get it to work with a large number of the documents without it running out of context space. So what I've done is I've created a subset of those documents, and I'll probably bring that back up in this back in the terminal window. Which is a much smaller set of the data, right? You can ignore the .text file. That's actually the At the Mountains of Madness file. Let's remove that. And so if we compare, ls rcdocs files, we're looking at 19 of the documentation files and not 56, right? And that's because we need to fit it into the context window, which we're much more limited in. And I just think that the way these pre-built components work is less good than the component in Llama Index that when I was using code. But this works in very much the same way. This reads the files from a directory. I've actually bind mounted that directory into the Docker container. And pulls the data out the file. And in the same way, it generates the embeddings, although this time I have used this other instance of vLLM running on CPU, again on the node that's running n8n, to process the data, and then set up the same thing, right? So again, let's execute that workflow and ingest that data. And we'll see it takes a little bit of a while. And actually, if we flick back, we can see it in HTOP, I think. Right, it's thrashing away processing that data. And so we've ingested those 19 or so items. And now in the same way as before, right, we can ask questions. So how do I log into Kathleen? Let's try that for once. That's one of our other HPC systems. And again, it generates that message. It's slightly horribly formatted because it's a JSON response, right? But you can then use that to run a chatbot. Now, this is the backend bit. There's a separate component to n8n, which is a node.js chat window you can insert into your existing project. So you can imagine a situation whereby you have this running on the backend with some workflow that you've built, and then you have your chatbot agent running on the documentation website for your service or whatever you're doing. And so it's been interesting playing this. It's been a slightly frustrating day because I like writing stuff in code, and it's actually sometimes quite hard to debug things when you have this kind of layer of abstraction, right? You don't see all the error messages. And I spent at least an hour messing about trying to get the context window stuff to be fixed. Um, but I mean, it does have a massive set of different agent tools and tasks that you can use to build these agents, right? And lots of integrations for talking to other software. Um, I've obviously done the inference locally, and by locally I mean within our cloud. But there's nothing stopping you connecting to a whole bunch of different model endpoints, right? We look at, so supposing we wanted to talk to XAI, right? There's a Grok chat mod. If you have an API key for Grok, you can talk to Grok. I think there's like Mistral and all sorts of things in here. So there's lots of pre-built integrations, and that's both a power and a curse, right? Because going back to the issues I had debugging some of the issues with the context window, it's quite hard to modify these pre-built components if they're not doing what you want. And that's the downside of using a toolkit like this as opposed to writing the code yourself. Personally, I would much rather write the code because I feel like 70 odd lines of code that executes locally and doesn't need to talk over a network is a much better way to build things than having all these containers running and talking with API keys over the network. But obviously, this is quite a good tool if you haven't learned to program. So yeah, I just thought it'd be quite nice to show off some of the things that we can do now that we have a cloud with a mix of CPUs and GPUs on it.